Alright, so here, we were here, that ends up being 215. So anything less than 215 is a lower outlier in electrical. So you can see that the minimum was 239, so there is no lower outlier for electrical. For the upper outlier, you get 383 as the upper boundary for an outlier. The maximum was 330, so there is no outliers for electrical. Let's try concrete. You do the same calculation. 262 minus 1.5 times the interquartile range of 46 for that one. And then for this one, you do 308 plus 1.5 times 46. So 262 minus 5 times 46. 193. Are there any values less than 193? Yes, there are. Alright, 308 plus 1.5 times 46. 377. Are there any values greater than 377? No. So there is a lower extremity here that is beyond the bounds of an outlier. So this is an outlier. There's an outlier for concrete. So for 12, the answer is the concrete distribution has at least one lower outlier. We don't know how many there are, but there's at least one. And the electrical distribution has no outliers. There we have it. 13. Here's this approximately normal. I made a little note on that on the previous lesson. So it's approximately normal. What this means is we can now draw a bell-shaped curve. It's called a bell curve, where most things are in the middle, and then it kind of distributes away as you get further and further away. The average is 86. And they do not tell you the standard deviation, but they tell you that 95%, and remember 95% is 2 standard deviations. So this is 95%. So they kind of do tell you the standard deviation. They tell you that 95% are between 83 and 89. So pretty quick little calculation here. The standard deviation is 1.5. All I did in my I just did 89 minus 86 divided by 2. So if I add 1.5, and if I add 1.5, standard deviation is 1.5, 1.5. And then if I subtract 1.5 minus 1.5, minus 1.5 minus 1.5. Standard deviation is 1.5. You can get that by knowing that 95% are within 2 standard deviations. That's a constant number. 95% are within 2 standard deviations. 14, which found can be reasonably modeled by the normal distribution. Favorite colors, that's categorical. Nope. Heights of tomato. We can find an average height of a tomato, so that's probably good. Percent of employees from a company who attend a company retreat. That's just a number. It's not really a distribution. You might get like 50%. The average number of siblings of all students at a particular high school. Again, that's just a number. That's not a distribution. If you did the distribution of siblings at a particular high school, you could have an average number of siblings. The parental guidance, that's categorical, so you can't find the average of something like this. B is the answer. 15. 2 cats. You got a 15-pounder and an 8-pounder. Cat's weight is classified as unhealthy if the weight is located in the top 5% or bottom 5% of all cat weights. Cat weight is approximately normal. So here we have it. Here is our cat weight. It's approximately normal with an average of 9.5 and a standard deviation, so approximately 68% of the data is within 1.5 standard deviations, so that 9.5 plus 1.5 and 9.5 minus 1.5. So this right here is 68%. Go up another standard deviation, so add another 1.5 and subtract another 1.5, and this is 95%. Gordo is still above that. Gordo is way up here at 15 pounds. And that's 99.7%. Okay, so Gordo is definitely in the top 5%. In fact, he is in the top 1% up here. He's pretty big. All right, Gordo's weight is classified as unhealthy, but Flacco's weight is not. Flacco is in the 16th percentile, we would say. So he's good. How did I get 16th percentile? 68 divided by 2 is 34%, so that's 34%, which makes this 16%, because this is 50%. So 16 plus 34 is 50%. So Flacco's good. 16. The distribution of number of transactions form approximately normal. We can draw the distribution once again, because of that approximately normal, with the mean of 478 and a standard deviation of 64. So we'll kind of go out like this. This is 64% of your data, so most of your data. Big mound there in the middle. So 478 plus, did I say 64%? That's because I just read that. 68% of your data is right here. 542 and 478 minus 542. Just kind of getting 478 minus 64. 414. Alright, so this is a typical number of transactions would be between 414 and 542. In fact, 68% of transactions are between here and here. Which of the following is closest to the proportion of daily transactions greater than 350? We got to go back down. We got to go down another. So subtract another 64, 350. Okay. So here's what I'm going to do to figure out which of the following is the closest to the proportion of daily transactions greater than 350. It's all of this. Alright. So this here, within 2 standard deviation, is 95%. So what I'm going to do is I'm going to do 95 divided by 2. That makes this here 47.5%, which makes this here minus 50, 2.5%. Okay, so again, this whole thing was 95%. So half of that is 47.5 minus 50 would be 2.5. So which of the following is the closest to the proportion of daily transactions greater than 350? It's all of this. So it's 100 minus 2.5%, which is 97.5%. 97.5%, let's see here. Which would give us E as the answer. Number 17, distribution of the amount of customers approximately normal with the mean of, okay, let's draw our curve. Approximately normal. You have 15.5. and a standard deviation of 1.72, which is 17.22 for the high end, and for the low end there is minus 13.78. Alright, so this is 68%. Which of the following is closest to the proportion of customers between 14, so now 14 is going to be like here-ish, and 16 is going to be like here-ish, if I had to guess where that would be. So if this whole thing is 68%, how much do you think this is? It almost looks like, I mean, we're kind of guessing here, aren't we? A little bit. 42%. It's interesting. These two are really close together. I can see picking B. This one's too big. If this is 68%, this is not 68%. This green area is not 68%. Definitely not that. Definitely not. That's too low. So one of these. How do you pick between those two? I mean, I know how to do my calculator. I just didn't think they would do that yet. So don't stress out about this question. We will do something like that in the future. 18. And here we have the last problem. The distribution of the number of moths captured per night by a certain moth is approximately normal with a mean of the following. 28% captures the fall below 76 per night. Percent of the captures fall, which of the following equations can be used to find the standard deviation. The z-score, which is like your percentile, right? So whatever percent you are, it's kind of like you can kind of get that from your z-score-ish, kind of, they're related. So 28% fall below 76 per night, which is the following equations can be used to find that. So your z-score is x minus x bar over the standard deviation. The mean is 103. And 28% of the captures fall below 76. I think that yeah, we haven't reached this point yet. So don't even worry about 18. We will cover 18 in the future. So basically, yeah, 17 and 18, don't worry about those. I'll make a note of that, so we're all good with that. Alright, so you just need to worry about up to 16 as far as these sorts of questions. These we will cover later when we get more into depth with the normal distribution. Alright.